this situation, so we're told that the gravel is dumped at 20 cubic feet per minute. Immediately I have to identify that this is dV over dt. So this is the very first step that I have to clarify. And the shape stays, and the base diameter and the height are always equal. So this, which is 2 radius, or radii better, and this, which is the height. How fast is the height of the pile increasing? So we're asked to find the h over dt. That's the question. Okay, perfect. So we have to remember the volume of a cube, and remember the volume of a cylinder. When we looked at this problem, I refreshed your memory as the area of the base times the height for the cylinder. So it's pi r squared h, but for the cone, it's the same thing divided by 3. So the volume of a cone is 1/3 pi r squared h. So I recommend all this to my students to remember them together. This is the area of the base times the height, and this is 1/3 of the area of the base times the height. So I recommend that. Okay, and the next step, I will write the volume, but I want to get rid of one of these two variables because I'm only interested in the h. And I know that they are the same. We're told that the height and twice a radius, 2 times r, or 2 radii, it's always the same. That's what the problem says. So whatever method they use to dump the gravel, they notice that the diameter and the height are always the same. Fine. So this is not an information that I can wait till the end, or I have to wait till the end. Okay. So the question here is when the height is 8 feet. This is our question. So at this point, I start with the cone. So the volume of the cone, 1/3 pi. So that's the volume. 1/3 pi r squared. R or r, it doesn't matter. It's h divided by 2. So times h over 2, everything squared, and times h. So after simplification, this is pi over 3 times 4, and h to the 3rd power. Because h squared times h is h to the 3rd, 2 squared is 4, 4 times 3 is 12, and that's pi over 12. So now I differentiate both sides. These are both functions of time. So then dv over dt will equal 3 pi over 12 times h squared times dh over dt. So of course I'll simplify. So this is given in the problem. I put it away, so what was it? It was 20, yes. So 20 equals pi divided by 4. This is going to be 8, so this is 64. And this is dh over dt. And this is what I'm after. So I will simplify. So 4 divided by 4, and this is 16. I'm checking. Yes. Okay, so then dh over dt, when h is 8 feet, is 20 divided by pi times 16, or 16 pi. So I'll simplify by 4. And the exact is 5 over 4 pi, and this is h over dt, right? So this is in feet. And I think it was feet per second, per minute, sorry. Feet per minute. And now I can approximate it. And I will use careful. It's 5 divided by, in parentheses, 4 times pi. And this is approximately 0.3979, still feet per minute. The other option would be to write 5 divided by 4 and further divided by pi. Or you use parentheses. Be careful. Good. Any questions?
Yeah, I have a question.
I'm ready.
So, going back to like the beginning when we substituted, so we have the volume, right?
Yes.
The first volume equation.
Yes.
Is it possible we could just substitute in our h value there, just get rid of the h, or get rid of at least the r? I mean, get rid of the radius because we know the radius at this time. Because the radius will be 4, and the equation was 1/3 pi r squared times h.
So you wanted to do this. So let's dictate.
So the volume equals 1/3 pi r squared times h. And then instead of the r, substitute in the 4, so it'd be volume equals 1/3 pi times 16h.
Okay.
And then, well, we take the derivative, so dv over dt equals, times dh over dt.
And from here we have that dh over dt equals
20 divided by
3 times 20 over 16 pi. So we will get the same. So
I
what?
don't think we get the same thing because.
But you understand why?
Understand why? What?
You understand why we don't get the same thing?
No, I do not understand why.
Okay. So from the very beginning when we talked about related rates, we said do not even look at this ever. Do not look at it until you find the h over dt as a function. After that, you can plug in. If you use this from the very beginning, that will be wrong.
Okay.
That's why I mentioned when I started the problem, this I have to use. Because at any point in time, this is given. From the moment they drop the first little rock or stone, this happens from the beginning of the process till they finish the process. So this has to come into play from the very beginning. But if you use this, which says, find the function and then plug it in, you are plugging it in before you find the function.
Okay, all right, thank you.
Thank you. So, just to make sure there is no confusion, do not look at this. Very good question, actually. Thank you. Because it's very tempting. On every problem we did in related rates, I said, please, do not even look at this. When it's whatever follows after the word when, find the rate of change of blah, 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 when, this has to go out of your mind till the very last moment of the problem, of the solution. This cannot be taken into account. This has to be taken into account. Because at any point in time in the whole process, this happens. But this says, find this, after you're done, plug in 8. If you plug in 8 before you're done and before you find the function, then you cannot determine what you're looking for. Good. I'm glad you brought that up so we can revisit it. It was a very good idea. Because it's so much information in this class, that's why I always review for each test, I always review for the final exam. So it's very important to revisit topics.